Welcome to the World Aquatic Health Conference. Learn, explore, network. October 13th through 15th, 2021. We just wish we were actually face-to-face in Houston, Texas. Hello, and welcome to the Virginia Graham-Baker Act Standard Just Changed. What your organization needs to know. Hello, my name is Steve Barnes. I am Director of Science and Compliance for Aquastar Pool Products. I am also the Standard Writing Committee Chairman for the Federal Drain Cover Standard known as ANSI APSP ICC 16, the 2017 edition. I'm also the co-chair of the PHTA Technical Committee. We're glad you're here today, and let's talk about the program. So we're here to talk about the Vgba standard just changed, what your organization needs to know. So we're going to cover the scope, what changed, why it changed, pipe size-based flow ratings, sump depth-based flow ratings, and there's going to be a caution of using maximum pump flow for Vgba 2017 compliance. And then finally, we'll touch on how do you enforce compliance, or how do you make sure your properties are in compliance with product that's from Vgba 2008 versus product manufactured after the deadline Vgba 2017. So with that, let's jump right in. First, let's talk about the scope of the Vgba 2017 drain cover standard. First and foremost, this federal law covers bather accessible and fully submerged suction outlet fitting assemblies. So if the swimmers can't get to it, it's not regulated by federal law. For example, if you have a wave pool and where the waves come out and where all the pumping equipment, inlets and outlets are primarily the suction outlets, all of those being behind a giant wall, screen, something that physically keeps swimmers away from those suction outlets, then those are technically outside of the scope of the Virginia Graham-Baker Pool and Spa Safety Act as it relates to suction safety. And so if they're not bather accessible, then they are outside of the scope. Likewise, skimmers and gutter overflow drains are not fully submerged, so those are outside of the scope of the standard. And they, skimmers have their own NSF 50 standards, so they're handled, safety and performance is handled differently for skimmers. It also excludes underwater vacuum port fittings. Again, they have their own standard. They have to be self-latching and locking, needing a tool to open them, and then the installation instructions, you'll have a valve. So that's where you connect a vacuum hose to a wall fitting. While fully submerged, it has its own standard and doesn't, the VGB Act does not apply. Let's take a look at what changed. Specifically, what changed is federal law and the Virginia Graham-Baker Pool and Spa Safety Act. And you can find the details of this at the Federal Register. It's under 16 CFR Part 1450. That's where you will find this in federal law. An aspect of the VGB Act is the Consumer Product Safety Standard. So the drain cover standard is actually a U.S. Consumer Product Safety Standard, and its designation is ANSI APSP ICC 16, American National Standard for Suction Outlet Fitting Assemblies, aka SOFAs, for use in pools, spas, and hot tubs. And while that's a finite list, any bather accessible or any aquatic venue with what we call swimming pool water falls under this category. So it's recreational facilities, could be wading pools, all kinds of things. So anything where we use for swimming. Okay. One of the most important things to understand about the changes to this federal law is it is not retroactive. The effective date of May 24, 2021 applies to drain cover manufacturers and to registered design professionals. So it's all about the suction outlet fitting assemblies and when they were manufactured or when they were designed and certified by a registered design professional. So we are the ones that have to meet the new standard. Products that were manufactured before the deadline remain compliant. Specifically, Section 1.1.2, existing product compliance. This is a quote, and by reference, it's federal law. Sofa components that were manufactured or installed before the effective date of this standard and that meet APSP ICC 2000, those that meet ANSI APSP 16 2011, shall be considered in compliance with this standard. Again, this is federal law. So if they were in compliance before the deadline, they remain in compliance now. That's important, and I'll touch on that again. So let's move on. What's new? Well, there's a couple of new categories: fire suppression sofas and maintenance drain sofas. Both of these are only used either in an emergency or when the pool shut down. In the case of fire suppression, we're talking about drains that would be in a pool so that a fire truck can be hooked up to it. Instead of dropping a hose, dragging it over the fence into the backyard, the pool can be equipped with drains and presumably big 4-6 inch pipe that would go out to a fire hydrant in the front of the house where it's accessible by a fire truck. Well, that truck, we don't know how big it is going to be or any of that. So we don't know flow rates. It's an emergency situation. So our focus and the reason for this, it was to give a way to put drains in pools when we don't know their flow rates. So all's required for compliance for these two categories is that the cover protect the opening and it be certified. Sump depth, flow rates, we don't know what those are, so they're not important. And so that's a new category. Another thing that's new to the standard is where Vgba 2008 certified product are going to say for single or multiple use, or single use only, or multiple use, that kind of a concept. Almost all of them are marked for single or multiple use. It's not really very helpful. And what really matters is it blockable or unblockable? And this is a designation that will now be on Vgba 2017 product. And why this is important is it's the dividing line between when you only need one, an unblockable drain, versus two or more for a blockable drain. The assumption is if it's blockable, smaller than 18 by 23 inches, that we assume one is blocked, even though they're tested as a single and have a flow rating while blocked. I'll show you that test in a minute. But we assume one is blocked, and then we use the flow rating of a second. If there's only one in an existing pool, we don't allow new construction. Building codes don't allow new construction with single blockable drains. We want to see 2, 3 feet apart, measured center to center, or 2 on separate planes, that kind of a thing. And I'd encourage you to look at ANSI PHTA ICC 7, the 2020 edition, and that's how to install suction entrapment avoidance systems. That's a field application standard. Okay, so on the left here, you can see a picture of the body blocking element over a channel drain, and you see the channel drain sticks out from underneath it. That qualifies it unblockable. This test gives it a flow rating, and those combined allow us to use flat and flush mount drains in pools with just one. And you can certainly use 2 or more. In that case, you add the flow rate together, because the flow rate of unblockable drains is the flow rate when it's blocked by the body blocking element. So when you start adding up 2 or 3 or more, each of those flow rates is assuming that it's based on that cover being tested while blocked. So unblockable drains Single or multiple use is a great option. I'm a particular fan of them for spas and play pools and things like that because they don't have to stick up. A blockable drain, the only way it passes the test is if it sticks up significantly off the floor of the pool. Otherwise, the body block element just seals it, pump cavitates, and the certification fails. So that's so now blockable and unblockable is going to be engraved on the cover in place of for single or multiple use. Now, that doesn't mean that the for single or multiple use has to come off. A manufacturer can leave that on, but it's no longer a requirement. So next, let's talk about policy clarifications. This has to do with the standard and the title, and then product type name change. So let's jump into this. So suction fittings were changed to suction outlet fitting assemblies. And this was important. It's a technical correction or technical clarification. Suction fittings is anything that supplies water to a pump. So as mentioned before, a skimmer is a suction fitting, but it's partially submerged. A vacuum port fitting is a suction fitting. It just has a cover when the hose isn't connected to it. So this is a clarification to talk about those fully submerged suction outlets. And we're talking about everything from the cover to the suction pipe. And actually with the new standard, because hair does get into suction pipes, the standard addresses not only the cover and everything in between, but even the first up to 16 inches of the suction piping or more if the cover manufacturer so chooses. You'll see some pictures on that, and that'll make more sense here in a little bit. So another change, a name change, was field fabricated outlets was changed to registered design professional sofas. So a field fabricated outlet is that water park kind of grate where it could be stainless steel, the size of a door or something, very large, designed and built and certified by an architect or a professional engineer. So because field fabricated outlets was frequently confused with field built sumps, that's just what's under any cover. Manufactured is the most common, but it also field built RDP kinds of sofas also, those unblockable. So anyway, name change for clarification. I would say one of the significant policy changes is a big change to Figure 2, specifically the 1.5 times the pipe diameter sump depth and then 1 times the pipe diameter out at the edge of the grate. That has been removed from the standard. So no longer is 1.5 pipe diameters base sump depths in the standard. So that's important to understand. It was never a requirement. It was an option for drain cover manufacturers that didn't design and sell sumps. So the manufacturers who did the universal, safety kinds of drains where it was just a cover that went on something that was previously installed, the idea at the time was if it's 1.5 pipe diameters down, then we're good to go. Now we know 1.5 pipe diameters is probably not deep enough to support a lot of the flow rates our variable speed pumps need, and we've learned a lot. So that kind of rule of thumb best practice has been replaced by actual testing. So sump design, pipe size, pipe depth determine each sofa model's flow rating, and you'll see some data and some testing on that'll help explain that. So the Vgba 2017 covers can still be tested and certified for use for those old Figure 2 sumps, but the manufacturer actually has to do it or have it done and publish that information. So just saying what's the pipe diameter and do the math won't cut it for a product that's certified to the new standard. All that means, manufacturer's going to give you those dimensions. Many of them are still using Figure 2 sumps, but now they're going to tell you how deep it is, and that's a requirement. So what replaces figure 2 is now a much simpler. It's just sump opening and sump depth. And this figure 2 supports definitions and technical stuff we manufacturers and certifying bodies use to generate the instructions, and a few other technical things like defining unblockable is based on the sump opening and some other factors. So, and then figure 5 is sump specifications. This is the detail that whatever sump a manufacturer has tested and certified, they need to publish those dimensions, and those are minimum dimensions. So if, for example, here B is the pipe depth, if that was tested and certified at 3 inches, anything deeper also qualifies. So if it's 5, 10, anything deeper. So these are all minimum dimensions, sump depth and all of that. Not maximums. You don't have to. You can use a cover certified for a shallow plastic sump on a deeper field built, and you don't need an engineer to sign off on that. You don't need permission from the manufacturer. You just have to confirm that the dimensions of the sump you're seeing in the field meets the minimums as tested, and that will be in the cover manufacturer's directions. So to reiterate, A, pipe size, and B, pipe depth for each sofa model is going to generate a unique flow rating. So you change pipe size or sump depth, go shallower, for example, then each of those is going to have its own flow rating. Now, I mentioned that the pipe is within the scope, and that's because the hair can reach down into the pipe. And so here you see this is actually F, and F is the dimension to keep pipe size changes beyond the reach of hair. So in an example of the Aquastar products, we know the hair is 16, so we're testing pipe. We don't change pipe size diameters until at least 16 inches, and that's typically happening anywhere from 18 to 24 inches, depending on the test configuration. And we publish that information. The point being is you could use a bigger pipe for the first 16 inches and utilize a higher flow rating, and then drop down to a smaller pipe size where higher velocity in a small pipe is not a safety issue, might impact energy efficiency and pump performance, but no one's going to get hurt. No one's been hurt on high velocity in pipe between the pool and the pump. We lose a lot of energy, pumps may cavitate, difficult to prime, a lot of business and customer service kinds of issues, but not safety. So that's the point of this. And just to reiterate, so each sofa model specification is to address hair entrapment hazards. So if you look at pipe size combined with minimum sump depth, then those equal a sofa model flow rating. You can go deeper, but not shallower, and you can't change pipe size. Each pipe size gets its own flow rating. So let's look at this kind of in a more practical point of view. So important sofa specifications. So what we're going to look at first here is how do we measure sump depth? Well, we're really not talking about the depth of the bucket. What we're interested in and what we're talking about is the depth of the pipe. So the suction pipe depth equals the minimum sump depth, not literally the bottom. So maybe that's something we can clean up in the future, but we're really talking about pipe depth because that's where the hair goes. The next element is why that minimum length before reduction, that F figure, is because the hair goes down through the cover during the hair test. And this is the ponytail type 2 test. There's a full head of hair type 1 test that you're going to see here in a minute. And it's kind of hard to see, but if we zoom in here, you can see that the center hairs of this ponytail are actually gone through this cover and down into the pipe. So here in the picture, you see the big red F. Well, that's a coupler and a reducer. So the pipe is, in this case, 3 inch for 16 inches before it reduces down to 2 inch, 2.5 inch, whatever the smaller pipe size is. And the point of this is we want the tested pipe size and those tested velocities to be controlled that are within the reach of anyone's hair. After that, it doesn't matter, as I mentioned before. So another aspect of the standard that did not change, which is why products certified previously remains compliant with this standard while supplies last, is specifically, so it's section 137, the flow rating of each manufactured sofa configuration shall be determined by the lowest passing flow rate obtained from two types of hair, the ponytail and the full head of hair, and the body block element test. So there's two hair tests and the body block test. And whichever of those tests has the lowest flow rating, that defines the maximum flow rate of that sofa. Now, I have underlined here, unless the sofa manufacturer specifies a lower flow rate, which shall then be the maximum allowable flow rate for that sofa. I point that out because we're staying way, way, way away from these limits as this is a company policy choice. We make everything from small hockey pucks all the way to unblockables and everything in between. So we are in a position to where we can be extremely conservative with our flow rates because we have multiple options and we fully bracket the pump range, pipe size range. So we have lots of options. And so therefore on any one cover, we're not pushing the limits. So just a heads up is just because a product can pass at a really high flow rate, the standard in federal law doesn't make us manufacturers certify it that way. That's just a choice we are making, and it appears that's probably pretty common. As I look at our flow rates, some 5,000-6,000 tests into this new standard, and look at what other companies' flow rates are out, we're all kind of in the same neck of the woods, and that's being driven by pipe size, and you'll see some more information on that here in a couple minutes. So here is the body entrapment test. So what's going on here is the pump's running at its maximum flow rating for that cover. 120 pounds of force is applied, and then the removal force is measured. And it has to pass this test 3 times to establish the body blocking flow rate. So what you just saw there happens 3 times. Now, if the riser ring, this is obviously a blockable drain, you can see it is definitely shadowed, literally, by the body blocking element, so you would need 2 or more of these. But another important aspect, going back to why the title of the standard was changed and we now talk about suction outlet fitting assemblies, is it's everything that was tested and certified. So if an installer does not use all the parts, for example, the lower ring here, the vented riser ring, then you run this test at this flow rate, it's gonna fail. So for a product to be certified, it has to be installed as tested and certified. So all those parts, riser rings, whether they be vented like this one or solid, all of those things have to be used. Internal baffles, some drains have internal parts that are designed to keep hair from reaching the suction port. Don't leave those out, and from an inspection point of view, they're important to look for. So again, it has to do with product being installed as it was tested. So now let's talk about the hair entrapment test. There's some, I sped up this video a couple of times because it's a 2.5 minute, or it's a 1.5 minute test, and I didn't want to take that much time. But in essence, what happens here is this is a full head of human hair, 16 inches long, measured anywhere from the scalp. So all of the hair is 16 inches long, and it's 5.5 ounces of it. It's a lot of hair, and you can see it is fed directly into the drain cover. So the first 30 seconds of the test is waving. The second 30 seconds is holding it in place, and then it's allowed to float, and then last it's pulled at 5 inches a second, and the removal force is measured. It cannot exceed 5 pounds of pull, and it has to pass this test 20 times per flow rating, and that's 20 times with this full head of hair, type 1 as it's referred to, and then 20 times with the ponytail we saw previously. So that's 40 passing tests to get one flow rate, and it's based on sump depth and pipe size. And then when you do it on the wall, that's another 20 tests of type 1 and another 20 tests of type 2. So there's only one set of body block tests, and those are always done at the highest flow rate, which would be the biggest pipe size that's used for any of these hair tests. So this is a very brutal test. The actual test didn't change. The only thing that clarified is, the sweeping motion needs to be uniform, where you position the hair, specifically targeting suction port. So if it's a channel drain, it doesn't do any good to be off at one end and your suction port's at the other. So part of the thing, it just clarifies, it's common sense. The standard clarifies that you have to challenge where it's challenging. And so that's what's going on here. Now, flow rate change. So let's begin to talk about the differences between the two standards. So when we talk about Vgba 2008 standard, there was basically two flow ratings, one for the floor and one for the wall. There's some exceptions to that. Some manufacturers were testing different pipe sizes years ago, and so you may have seen, a 2-inch flow rate versus a 3-inch or 2.5 or whatever. So it's been in the market, but it wasn't required, okay? And so, and the two flow ratings, because there was only one or two, would have been marked right on the cover itself. Well, now with the Vgba 2017 standard, we're going to have multiple flow ratings. So for the floor flow rating, there'll be a floor flow rating for each pipe size, each pipe orientation. Is it going out the floor of the pipe, kind of like the figure 5 we saw previously, or is it going out the side of the sump, like the that product I showed previously? So each one of those results in a different flow rate and different test results, which is why it's appropriate. And then we do it all over again for the wall flow rating for each pipe size, pipe orientation, and pipe depth. The cover's going to be marked for flow rating C instructions. So now when some of these covers, these universal covers, have, I don't know, I think we're up to 12, 15 flow rates. Well, obviously, there's no way to put all of those engrave it on the cover. So now that information will be provided in the product specifications. So you can get at those via the instructions, websites, all those kinds of things. And the important thing is here is you get to know what the flow rate of a given cover is before you purchase it. And as I mentioned, we have lots of different covers. So don't just assume that the 10-inch or the 8-inch that you've been using historically is going to be your choice going forward. They behave very differently when you test them with different pipes out the bottom versus the size, different pipe sizes. There's a lot going on in those hair tests, and it's the hair test that's driving all of this. So when we talk about product specifications, here's again an example of a Vgba 2008 certification. This is a spec sheet. And you can see, well, it's hard to see, it's so small, but there's a flow rating for the floor and another one for the wall. Didn't matter what pipe size, didn't matter if it was a sump with a pipe out the bottom, out the side. It was just two flow rates based on two different sets of tests. Now, it was the same test. It was 20 ponytails, 20 full head of hair, and 3 body block. But then those flow rates could be used for anything. And so that was a big change. So now when you look at the specifications for the same product, the Vgba 2017, now we've got a lot more going on. So, the drain covers typically have multiple flow ratings, and you can see here, this one has a lot. So another element you see down on the bottom is head loss curves, and I'll talk about those in more detail here in a minute. But the purpose is now any product certified at different pipe sizes and sump details and all that kind of thing, there's going to be a head loss curve. The manufacturer's supposed to provide one, and the certifying agencies are supposed to require them. So we'll see how that plays out, because it's not easy, I'll tell you that. But in any event, the purpose of the head loss curves is to help designers and predict what the flow rate's going to be. And you're going to see there's some big impacts on pipe velocity based on pipe size. So let's look a little closer here. So now this is a zoom in of that data. It's sump depth. And if you look, we're going to focus on sump depth, and let's look at 3-inch pipe, 0 depth. Okay, so it's a 3-inch pipe out the bottom. That's what the little B stands for when you're seeing Aquastar stuff. The sump depth, that's the depth of the pipe, was 0, so it was flush with the plaster. And then it has a Vgba flow rating of 138 gallons a minute. Now let's look at that same exact cover over 3-inch pipe that's 3 inches down. So instead of being flush with the floor, it's down 3 inches in the bottom of a funnel, kind of like that figure 5 we've been looking at. That flow rate is 170. And so the difference between 138 and 170 is not as much hair is going into the pipe. Therefore, it doesn't take as much force to pull it out. Excuse me. Now, one of the points I meant to make earlier is when we talk about that 5 pounds with the pump running full tilt boogie, is 5 pounds is about 3 twisted hairs, certainly no more than 4. So if you take 4 hairs and twist them and try and break them, that's going to exceed 5 pounds. So if the whole hair gets stuck in a cover, we see, well, our system will quit pulling at 20 pounds because there's no point in ripping hair out of a test mannequin. And it just stops. So that's why flow rate, pipe size, and depth is so important. So impact of pipe depth is really important for flow rating. Now, it's important to know that 3-inch, or let me jump up to the 1.5 inches at the top of the screen. So you see 1.5 inches at 0 pipe depth is 63, because that's small pipe, and the hair definitely plugs it up. Now, you can have a 1-inch or say a 3-inch pipe depth sump. The flow rate still remains 63, but we know from additional testing since this was published that if you go deeper with 1.5 inches, you're going to get a higher flow rate. Again, the physics are the same, less hair goes into it. But sump depth is really, really important to understand from a design, installation, and compliance verification. So next, let's look at the impact of pipe size. So same set of data, but we're going to look at here now, we're going to look at this 1.5 inch pipe. It has a flow rating of 163, 2-inch as 119, 2.5 is 119, 3-inch is 138, and if we go to 4-inch pipe that's down 5.2 inches, in this case it's a big side port, it was that product shown previously, it has a flow rating of 250. So just as a point of reference, this particular product, when it only had one flow rating for the floor, it had the same flow rating for the wall. They were both 170. So you can see, and that was tested on big pipe. So when you can see when it was tested on smaller pipe, the flow rating went down, and when it was tested on bigger, deeper pipe, the flow rating went up. And again, these are conservative numbers. The goal here, this is a 10-inch universal, and if you happen to have 4-inch pipe in a pool, it behaves really well. So anyway, you can trust these flow rates from Aquastar and other manufacturers. I have a lot of confidence in it. So that gives you the impact on pipe depth and pipe size. So now let's, a caution, a very important caution. We, Aquastar, have been teaching our customers, look at the max pump flow of a pump curve, and if you select a cover that has a flow rating higher, you just know you're done with VGB compliance. Well, that's fine until you start using smaller pipe sizes with these new big variable speed pumps, that their pump curve goes way beyond what you can, the amount of water you can get through 1.5-inch pipe, you know, because it's from the pool back to the pump, through a filter, valves, back to the pool, all through 1.5-inch pipe. There's just no way you're going to get anywhere near 160 or 200 gallons a minute through a variable speed pump. What happens is it cavitates. We use 2-inch pipe for draining in the lab, and it cavitates when we're draining tanks 8 foot underwater. In the lab's only, you know, it's only 30 feet to the pump. So the point here is safety and Vgba compliance only requires SOFA model-specific flow ratings to be higher than the actual flow through any one cover. What's really happening in the pool is what matters. Now, it's easy on a public pool with flow meters to look at what is your actual flow, and if it's 1.5-inch pipe, it's not going to be anywhere near the limits of the pump. It's going to have to be throttled, or it is throttled by nature of the restrictive pipe, backwash valves, control valves, that kind of stuff. Just won't allow, the resistance of the system is not going to allow a pump to get anywhere near its NSF certification, and that's what you see on the edge of a pump curve. So here's, let's give you some visuals on velocity. So we're going to take a look at 1.5-inch pipe. Let me start this video. You're going to hear me speaking, and so it's a variable speed pump, and while I recorded this, I gave you the flow velocity. So I have a variable speed pump, and I bumped the speeds progressively. They were preset at these various velocities.
6 feet per second. 8 feet per second. 10 feet per second.
Pump was running the whole time, you just couldn't hear it.
24 feet per second.
So we're at 152 gallons a minute starting to cavitate. Just bump the speed again.
27 feet per second.
So what you're seeing is water air. It gets so bad that the air goes back to the pump and the pump starts cavitating. Those systems go to the max flow of this particular pump is 225, and looking at recorded data, it never, I think I saw 190 briefly. What happens is the pump catches or starts cavitating, it just can't. There's no way it can reach its maximum flow rate. Another aspect of this demo is this is only 16 inches of 1.5-inch pipe before it jumps to 6, and then ultimately 10 inches is what goes through our flow meters and all of that. So we can move a massive amount of water with almost no head loss in this lab. So what we focus on, because it's in the standard, is we control the first 16, 18 inches of pipe in our testing, because that's all the more the hair will reach. And then that's how we're able to do most of our testing. If you do the math on those flow rates that I showed you previously, almost all of those are tested, the Vgb flow ratings up at 15 to 20 feet a second, because we test at 125% of the Vgb flow rating. So if a cover has a Vgba flow rating of 100, it passed the 40 hair test at 125. And so regardless of wherever, that applies to all the testing. So again, the point being, is, and I want to really emphasize that the maximum achievable flow rate when tested with 1.5-inch pipe was 158 gallons a minute, resulting in a Vgba 2017 flow rating of 126. You're going to see that number a lot. There's similar numbers for 2.5-inch pipe, 3-inch pipe, because what we found is we take the pipe to almost the cavitation level, we stay right below it, and then we test the cover there. And when it's a shallow sump and real high velocity, that cavitation, that vaporizing water, just totally tangles the hair, and it's game over. It will not come back out through the cover. So there's no point in testing at the max flow of the pump, because you can't get there. Now keep in mind, the design flow rate for these, for 1.5-inch pipe, we test at 158. The actual code limit is 38 gallons a minute for public pools, and I think it's, I forget the number, it's like 60 gallons a minute at 8 feet per second for residential. I mean, the VGBA flow ratings are double and triple what can be achieved in the field. I mentioned it's a brutal test that's very conservative. This is an example of why I say that. So now another thing to keep in mind on this subject is most variable speed pump curves far exceed the flow rate. So while installed systems experience pump damaging cavitations below the VGBA 2017 flow rating. Let me translate that gobbledygook. Basically, the tested VGBA flow rates in the real world, we're not going to get there. The pools self-regulate. So if you have 1.5 inches and a 3 horsepower pump, it's not going to run at 160 gallons a minute. It can't. Physics cause the restrictions and all of that you've seen video of just doesn't allow it to happen. If somebody tries to run these pumps at full speed on these small pipes, even though they're not reaching the VGBA limit, it's going to destroy the bearings. It makes noises. It's a mess in the marketplace that's kind of self-policing. The most important things is these systems are not going to exceed these flow rates, at least not the ones I have experience with. I can't speak for other manufacturers' products. So I mentioned previously that there's the head loss curve. And so what I want you to look at is K, the head loss curve down at the bottom. It's, the maximum flow on this cover is 250, and you see that with a 6-inch sump out the bottom, the head loss is like a fraction. We didn't even move a vacuum gauge off of zero. Now go to the other extreme on this chart, curve A. That's that 1.5 inches. The reason you see it's got a flow rating of 63, as I've been saying, is you can't get enough water through it. So really the head loss curves are driven by the pipe size and the connection. And so this demonstrates the importance of testing every pipe size, but then it gives you the value of publishing this, because there's been a best practice rule of thumb that says we're going to assume drain covers have a head loss of 1.5 feet of head. Well, when I look at this chart, that's, actually that it's just not real helpful. It maybe is a good starting point for hydraulic calculations, but I think what I've personally learned from thousands of tests is a more accurate head loss calculation would be to, by and large, if you're talking about this cover, ignore it and just use your calculation from, pipe to the pump kind of a thing. Will give you more accurate results than plugging in some arbitrary number. In any event, they're really small numbers at the VGBA flow ratings, which are really high pipe velocities, so the head loss on drain covers is not a huge deal. So let's kind of close this out by talking about how do you find out the certification mark for a given cover. So as I mentioned, this is a rolling product change. So you're going to have product in the field, in pools, that's absolutely VGB compliant and safe to use through its service life. And so there's a lot of new and helpful information based on the new standard, but there's nothing scary about the old information. We just can do better. It's continuous improvement kind of a thing. So drain covers that we fall under the VGB 2008 rules, as I've been calling them, will be marked with ASME ANSI A112-19-8, and it could be the 2007 edition, 2008A, or 2009B. All of those were adopted into the VGB Act at the time. You can find Federal Register, back at the, a decade ago. And then during the transition from ASME to APSP, now the Pool and Hot Tub Alliance, in the interim, they were marked VGB 2008. That's why you see me refer to that. And then after 2011, they could be marked with either VGB 2008 or APSP ANSI 16 2011. In a lot of cases, they were marked with both. Long story short, all of those mean the same thing. Follow those instructions, which mean you can still use figure 2, 1.5 pipe diameters, all of that. We've never had anyone get hurt on it. We just know we can do better by providing the actual tested dimensions in the future. And that's what we do with Vgba 2017, in which case if it's marked that way, you follow the new rules. Now, I've shown you an example of our 10-inch retrofit that had 2 flow ratings to the Vgb 2008, and now it's got 14 or 15. You can absolutely use the new flow ratings with those old covers. You cannot use a new cover with that old flow rating. So for example, if the pool you're retrofitting has 1.5 inch pipe, you can't use the 170. Not that we could get there anyway, we talked about that, but you have to use what actually is going on in the pool. And just as an important reminder, we've seen this before. This is federal law, 1.1.2, existing product compliance. SOFA components that were manufactured or installed before the effective date of this standard, that was May 24th, 2021, and that meet APSP 16, translation VGB 2008, any of those prior standards, shall be considered in compliance with this standard, meaning the 2017. So this is a rolling change, just like heater efficiency in 2013, when the federal government moved the heater efficiency from, I think it was 76 to 82. Product that was manufactured before the deadline could be on the front of a truck. Product manufactured after the deadline could be on the back of the truck. You go to somebody goes to buy one of these heaters, you don't know which one you're going to get. It's a rolling change. Exact same concept as the drain covers. And with that, I thank you, and we'll take some questions if we have time.